Hello friends, in this video we are going to discuss about the Schottky diode. So in a Schottky diode, actually it is a metal semiconductor diode, and this diode will have some rectification property. The symbol of the Schottky diode is like this. This is the symbol of the Schottky diode, where this port is the anode port and this is the cathode port. Also, Schottky barrier diode is also called as hot carrier diode. And the major application of the Schottky diode is that it is used for high frequency rectifiers. It is formed by connecting the metal with a moderately doped N-type semiconductor. In this way, a rectifying junction is formed in between metals and semiconductor. So let us see the block diagram of a Schottky diode. The block diagram of a Schottky diode looks like this. This is a moderately doped N-type material, and with this there is a metal contact. Now this is the Schottky junction, and this part is the metal and this is moderately doped N-type. So this is a cathode and this will be the anode, and a positive terminal of the voltage will be applied at this terminal and the negative terminal will be connected to the cathode terminal. That's why a current will flow from the positive terminal to the negative terminal. Now this current that is flowing inside the Schottky diode is due to the majority carriers. That means in this case, since it is a N-type, so current is flowing due to only free electrons. Now Schottky diode is also called as a unipolar device because only one type of carriers, that is the majority carriers, are flowing inside the device, and the VI characteristics of the Schottky diode will be similar like the PN semiconductor diode, and it will look like, if I plot IF in the y axis and if I plot the voltage in the x axis, it will look as this way. Now since there is no minority carrier flowing inside this device, so minority carrier storage time will be 0 because there is no flow of the minority carrier inside the device. For this reason, this Schottky diode is very useful for switching application because it will have a very low switching time between the forward bias to reverse bias. That's why we can say that the storage time of a Schottky diode is 0, and the reverse saturation current, that is the IS for the Schottky diode, will be large compared to the normal PN diode, and the forward voltage needed to just on the Schottky diode is 0.3 volt. So, we can say that the forward voltage of the Schottky diode is 0.3 volt. Now, since the Schottky diode has a very low forward voltage, so we can say that Schottky diode has a very small turn on time. Hence, faster operation can be possible compared to the silicon normal diode. Now, if we draw the Schottky diode characteristics along with the normal PN junction diode characteristics, it will look like this. So, this will be the forward voltage Vf, and this is the current flowing through the device. Then for the Schottky diode, the characteristics will be like this, where this turn on voltage is 0.3 volt, and for the normal PN junction diode with a silicon material, the characteristics will look like this one, where this will be the cut-in voltage of the normal diode. So, the blue one is for silicon PN junction diode and the black one is for the Schottky diode. Hence, the Schottky diode can be used in collector base junction of a bipolar junction transistor, so that the transistor cannot enter into the saturation region. So, this is all about the Schottky diode. Thank you.